feel free to come get some more sheets. Did anybody want a blank sheet? Since I'm saying that right now, we're good. People got the ones they needed. Yeah. Here we go. So 12.6 is, if you recall from last year, the law of cosines. So in last year we talked about this. In trigonometry, when you have right triangles, it was on the MCA, I think it was on the MCA, it said SOHCAHTOA or something uses what kind of triangles? Right triangles. Now, it does use 30, 60, 90, 45, 45, 90, and all the other right triangles. Unit circle is just the 30, 60, 90, 45, 45, 90, and then the quadrantal angles as well. But that, the unit circle is those two special right triangles. SOHCAHTOA uses any right triangle. Also, to solve for right triangles, you would use Pythagorean theorem. So you have kind of four things when you do right triangles. You have Pythag and you have SOHCAHTOA. When you get away from having right triangles, we have two different things that we can use to solve. And 12.6 here is the law of cosines. So when would you use the law of cosines? Well, when you have a non-right triangle, and then specifically certain parts of a non-right triangle. So the law of cosines, if you have some triangle like this, and it doesn't matter which one's A, B, or C, we'll just go like this. And remember, this is angle A, then we have little a, little b, little c. The law of cosines is this. It's typically written, if you asked, for it, it will be written with c squared equals a squared plus b squared, which looks very much like your Pythagorean theorem, because actually that is the Pythag. Then, however, it will go minus 2ab cosine of angle C. But it is not respective to side C having to be here and angle C there. It's just if you were trying to solve for side C, let's say C would be on it by itself and then you would have everything over here. But you could, so if you say, hey, what's the law of cosines, and you look it up, you're probably going to get that. But if you were like, hey, I actually want to solve for side A, let's say, all you would do is take A and C, swap it, and then angle C and swap it with angle A. So if we're solving for side A, we would say A squared, and then instead of saying A squared plus B squared, it would be, just C squared plus B squared, the other two sides, minus 2 CB or BC, and then cosine of angle A. So you could have any, you could switch the sides around like that. So law of cosines can get switched around like that. So let's solve some here. Again, these would be with non-right triangles. And make sure that, I don't know what I was going to say, 12, C equals 17, and angle A equals 74. Okay, so like on this one, they're actually just going to have you, instead of solving the entire triangle, they're going to say just solve for like side A. Now, when does law of cosines work for us? Meaning, does it work when you're given any information or a specific type of information? So I already told you it's for non-right triangles. But then let's consider specifically what happens like with a triangle when you're given, two sides and an angle, or three sides, or if you remember from geometry, it would be like SAS, like SAS, do you remember that? Or SSS, or so with this, it's the same way. You can draw like a little picture if you want, and say, okay, if I have, a triangle, A, B, C, it doesn't, dimensions, just to get a look of it, doesn't really matter. So side B is 12, side C is 17, angle A is 74, right? That's what you've been given. So what you have is convenient, A for angle, and then S for side. So you're given SAS, where you have an included angle. Is this the right information to be able to use law of cosines? My guess is it is, because it comes from the law of cosines section. But we plug in and we say, I want to find side A that's unknown. So if I want to find side A, you would say a squared equals, and then your other two sides squared, which would be, 12 squared plus 17 squared minus 2 times 12 times 17, and then times the cosine of the angle measure opposite of the side you're looking for. So if this is A, you have to use angle A, which, okay, it was given to us, so that's really nice. Now at this point, it's simply just calculator work. You just plug that all into your calculator, hit enter, and then don't forget at the end, sometimes people forget that, make sure you take the square root at the end. So plug it into your calculator, and just go 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 74. Hit enter, or and then do the square root, or do the square root of all of that. It doesn't matter which one you want to do. So, and you end up with a value for A. I'll give you just a second to make sure you're plugging that in correctly into your calculator. And usually people catch that they forgot to take the square root because you get a pretty large number in comparison. You're like, that seems a little bit off. Oh yeah, don't forget to take the square root. Haley, what'd you get?
17.904.
17.904, okay. So that definitely seems within the ballpark of numbers that would work for us, not guaranteed necessarily. Other people are doing it too, but this seems reasonable. Anybody else seeing a 17.904-ish or so? Okay. So we're going to go with 17.904, looks good. Now, what if we had been given same information, if you're taking notes, you don't need to write this down, I'm just going to reference this. Let's say you're given angle B here, like that, yeah, B is equal to whatever, 74. Let's just say the same numbers, but it was angle B instead. So then when you're like, okay, law of cosines, and you set this up, you have this and you have this, and we say, okay, that's A, that's B, that's C. So we were given 17, we were given 12, right? And then we were given 74. So what we would have here is side angle, right? So this would be side angle. Could we solve for our unknown side of A, right? That would be we already know C and we know B, so what could we solve for A? You're like, okay, I'm going to do law of cosines and say A squared is equal to, again, 12 squared plus 17 squared minus 2 times 12 times 17. Now, careful, if you say cosine of 74, remember, A, being side A, has to match with what angle over here? Angle A. Did they give you angle A? No. So if they didn't give you angle A, could you plug in angle B for that? No. So you can't plug in there, in which case you would actually have to do law of sines, which we'll talk about tomorrow, but that's the law of cosines. They're like, okay, not the right information for me. Okay, so you have to pay attention to that. Don't just say, oh, here's, because at some point, like on the test, it'll just be say solve. It won't say use law of cosines, it'll just say solve, and then you got to think through, okay, well, that didn't work because I was given SSA. SAS works. That's good. Let's do another one that works for us. And let's say you have, let's do this one. A equals, some decimals in here, 1.2. B equals 2.4. And C equals 2.0. Okay. And then what they're asking for is the smallest angle. Okay. So they give you 1.2, 2.4, 2.0. So they give you the sides of the triangle, so you could, draw a quick picture if you want. A, again, the sketch, doing an appropriate sketch can be helpful. But again, it's not necessary, so I wouldn't get too caught up in it. But visually, if you need to, it could help you, for sure. Like if you look at that and you think, is 1.2 doesn't look longer than 2.0, so the picture's a little bit off. So that's okay. There's your triangle. You're given 3 sides. If you want to find the smallest angle, we got to think through our geometry knowledge. Which one's going to be the smallest angle? A. Why is A going to be the smallest angle? Opposite the small side. Nice. So you were trying to find what angle? Angle A. So if you're trying to find angle A, you have an unknown angle, but you know all three sides. If you come to the law of cosines, and you can think, okay, if I know 1, 2, 3 sides, know those sides, I can fill in for all the small letters, and then there's one unknown, and that's the angle measure. So does the law of cosines work when you're given all three sides? Yeah, because you can fill in for all three sides. So if you're given SSS, then law of cosines works. So now we look at this, we say, okay, how do I solve this? Well, if I'm trying to find angle A, and I'm going to set up, and I have the cosine of unknown angle A, I just need to figure out which letter goes here, right? Well, don't forget, in the law of cosines, whatever side is here matches the angle here, right? So if angle A is what I'm looking for, then I need to make sure side A is over here, and then your other sides are on the inside. So cosine A, so then I go, okay, side A needs to be on the left-hand side, and then I go 2.0 squared plus 2.4 squared minus 2, like this, and then I solve. Now here, the error occurs is when you're doing a little bit of algebra work, the error occurs by people taking 2.0, 2.4, and then they subtract the 2 times 2 times 2.4. They lump all this part together, and that's illegal. Why is it illegal? Because this is attached with multiplication. So you can't just combine all those, right? What you need to do is just solve like a basic algebra problem, although it doesn't look basic, but you take these two, right, and subtract them from the other side, and then you would divide by a negative, whatever 2 times 2 times 2.4 is, and then you'll end up with just cosine A equaling something, and then you take the inverse cosine. So, you can do all that. Be careful not to use any rounded values when you go to do this. I'll show a couple steps just to make sure you guys are, understanding. So when you go to do this, make sure there's no rounded values through the problem. You got calculators with incredible ability and easy to read, usually cosine of A. And you should be able to on your calculator, like do this, hit enter, and then do the inverse cosine of your answer. Or you could, do cosine inverse and then type in that whole fraction, 1.2 squared minus 2.0 squared minus 2.4 squared divided by, negative 2 times 2 times 2.4. So, and then do the cosine inverse of all of that is available. You could do that. Then when you end up with an angle A, you should end up with not necessarily a tiny angle, but you should end up with a smaller, it should be less than 90, right? Because if it's the smallest angle, it's got to be less than 90. And so what do we end up with for angle A when we're all said and done? Who's got it for us? Maybe an attempt at it. Did you find one less than 90? What'd you get?
29.9.
29.9, is that anybody else? So that's less than 90 and it's a small angle, 29.9 degrees. Seems reasonable to me, 29.9 degrees, okay? So there you go on that one. So side, side, side. Make sure you can use your calculators to get those. Okay, so then if we take a look at page 583, go to page 583. You've got some story problems on here, page 583. And so usually, again, the issue is just setting up the problem, because once you have like your triangle drawn and you're like a little comfortable with the law of cosines, you're just plugging into the calculator, hitting enter. But it's a little bit of a challenge to get stuff set up. So go to page 583 and let's go ahead and take a look at number 2 here. Okay. So on number 2 it says 2 planes leaving the airport at the same time, one flying due west at 500, the other flying due southeast. Now we want to, this is so number 2 on page 583. So when we, a little picture, like I said, can prove helpful, and a good picture can yield points. So it has the same airport, right? And then it says one is flying due west. There we go. So which way is west? You have to know which way is west. West is going to the west, right? So that's 500 kilometers per hour. So I'm just going to make a note. He's going 500 kilometers per hour. Now the other one goes southeast, right? So how do you figure out southeast? Well, south, right, goes down, and then east is that way. So southeast cuts, if you don't know this, I mean, you should know this. We've talked about it at some point, or you should have seen this. Southeast goes down at this angle right here. It's a specific angle. What angle measure would be, like at southeast, what angle measure is going to be here and here? At southeast, yeah, 45. So that's important to make a note of. They don't tell you that, but they don't have to because it's southeast. It's a given that it's 45. So something you can make a note of is that west and south, that's going to make a 90. Southeast is going to make a 45. So as you're drawing this picture, what angle measure do I know I just made for this, the full angle right there? What, 135. So a picture would need to yield something like that as well, that you did a little bit of understanding there. We haven't done any like trig work yet, we're just drawing a picture. Now it says this one was going at 300. Now in the end, I don't think it's going to be just 500, 300, because it travels for, how long do they travel for? They tell you. 2 hours, right? So at 2 hours, how far did this plane actually fly for? If it's going 500 an hour, like, right, 500 an hour, and it goes for 2 hours, how far is it? 1,000. And then how far would this be for 2 hours? 600. So that right there, if you had a picture, it's a little bit sloppy, just with like little extra 45s and stuff, but you know, crossed out. But that right there is going to yield a point at least, because you drew a picture, you understood what it looked like. Now we've got to math it out. And I believe they just asked what's the distance between the two, right? And so what we're looking for is D right there. Now, when you look at that picture, what have you been given? Have you been given, you know, angle, side, side? Have you been side, angle, side, 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 angle, angle, angle? What have you been given? We look, we say, okay, we know the side, we know the angle, and we know the side. So you have been given, right, SAS. Based off our limited work, we come back over here. If you were given SAS, were we able to use law of cosines? You bet. And so we say, okay, that one's going to be law of cosines. Don't do SOHCAHTOA. Some people try to do SOHCAHTOA. It's not going to work. Or they Pythag theorem it for sure, right? We panic. You're like, I don't know, a squared plus b squared is equal to c squared. Don't do that. All right, so law of cosines, we have unknown side, d squared equals, and then you can just make sure, do you know the angle opposite of d squared, and it's cosine of 135 degrees, okay? Then we just fill in the sides that we're missing, which would be the 1,000 and the 600, right? So then we go, okay, 1,000 squared plus 600 squared minus 2 times 1,000 times 600, like that, all right? Then you hit enter. Now, should D be bigger than 1,000 and 600? Yeah, it's gonna, because it's opposite the largest angle, right? So try to think through these sides that you're getting. They should match, like something that makes sense for what you're doing. Alright, what do we get? Something over 1,000. It's got to be less than.
1,486.
Yeah, I was gonna say, it has to be less than 1,600. 486?
Yeah.
Okay. Why do we know it has to be less than 1,600?
Because then they wouldn't, the height, or the long side wouldn't touch if they like stretched all the way out.
Yeah, any two sides have to add together to be greater than the third side, okay? So that's a side note there. All right, let's take a brief look at number 7. A baseball diamond is a square 90 feet on its side. The pitcher's mound is 60.5 feet from home plate. How far is the mound to first base? So, you know, number 7 here, if this was to be on the test, it's a square like this, shaped like a diamond, right? I guess you have to know a little bit about baseball, but there's home plate, right? And then there's the pitcher's mound out here, okay? And then this makes it 90 now. In this case, and then these are all 90 feet, right? 90 feet, 90 feet. And so on number 7, it says a baseball diamond is a square 90 feet on the side. And then you have this pitcher's mound. I'm going to get rid of that excess. Put a dot there. There's our pitcher's mound. It says the pitcher's mound is 60.5 feet from home plate. How far is it from the mound to first base? So we know this distance is, they just told you, from the mound to home plate is 60.5, and then they are looking at what is that distance right there, right? So that distance right there. So we'll just call that D like that. That looks, I think that looks good. Okay, so I mean, if you look at the picture kind of looks like it's going to be like a 90 there. Don't go based on the picture. You know, this would be a good picture to draw. Like it would be, you know, give you a point probably at that point. But if you say, oh, it cuts it at a 45-degree angle, not necessarily. As it just says it's 60.5, it doesn't say it's halfway in between. So it just says 60.5. So then when we look at that though, we want to find this distance from here to here, right? I believe it just said from the mound to the, make sure we're finding the right thing, from the mound to first base, right? So if I want to find from the distance from the mound to first base, it is, and don't think, oh, it's directly across, there we go. Okay, so we can look at that one tomorrow. 12.6, right? We just did 12.6. That one I won't make do tomorrow because we'll probably struggle away just a little bit on some of those story problems. Take a little bit of time. So we'll make 12.6. We'll do that. Make that due Wednesday along with your MCA corrections. So make sure to get your MCA corrections done by Wednesday as well.